There is a wealth of uh, open access data available all over the place, including at the local level, that people don't really take advantage of. And um, for example, go to data.cityofgainesville.org and choose to see all data sets. And there's this really interesting data set, which is all the crime incidents from 2011 to present, right? Like, that's hugely interesting. And I think all of us as public health people and researchers, we would love to see this, right? But if you look over here, this has only been viewed, not even used, just viewed 142 times. I bet 100 of those times were me, and 42, I don't know, but literally, almost literally, nobody's using this data. And if you look in there, every single crime through yesterday is reported. The only ones they take out are like sexual violence and things like that, but just about every single crime with a location, what happened, etc. And this data is easily exportable as a CSV, or you can use APIs to access this data programmatically. So now what I'm going to do is a quick walkthrough of how to use Gainesville data, or one way of using Gainesville crime data, to show you, big data not so much as something computationally difficult or large, but big data more as an idea in an era that we're living, where data is available for everybody, from everything. So we're going to read in this Gainesville crime data into R. And of course you could use any other software. R and Python is probably the easiest to access that data programmatically, that is without having to download and stuff. And then if you look at this data, we have an ID, a narrative, what happened, when it was reported, where it happened, location, etc. So that needs some manual cleaning. I won't spend much time talking about that, but feel free to look through that if you're interested in the dirty work. And it needs some cleaning of dates and stuff, and you can see this is the dates of crimes. And we've got our data in now. We're going to group it up by date and just kind of look at the general trend line of crimes in Gainesville, right? This red line is using local regression. You can see there's a lot of variance. One day there might be 25 crimes, another day 80. But on the whole, there seems to be like a slight decline through March, early April 2015. So that's a good thing. Here's a quick helper function to look up crimes by a certain theme, right? So this function I wrote is called crime, and you can pick a theme that you're interested in, like robbery. And then you can see the trends and examine that data specifically related to that. So let's start, just for an example, assault. And what it does is shows us the number of assaults. You can see most day there's 0 assaults. Some day there's 1, 2, 3, and one day in late 2014 there was 4. You can see this red line again is local regression to kind of show the trend, and the blue line is linear regression. The fact that they're really similar means there's kind of a linear, I wouldn't even call it a decline, it's just kind of flatlined. Assault on average is about half an assault a day, or 3 to 4 assaults a week. If we want to look at details, we change this option to say false, and we can then look at a table of different kinds of assault, right? The most popular one is simple assault. Assault on a police officer happened 13 times. Dating violence, aggravated assault is 12. Domestic assault is 27. And of course, we could re-specify our term if we were just interested in looking at those. But you can see we have this data frame over here now called assault. And I've got the info on every single assault that the police have ever reported in Gainesville for the last 3 years. So that's kind of cool. If you're a paranoid parent, you might be concerned about something like kidnapping. So we could make a data frame called kidnap and look at the incidence of kidnapping, and you can see that it's 0.00001, 0.00001. So the probability is pretty low. This blue line tells us the trend. It starts low and it's gone even lower. And now we have this data frame called kid, and so in the last few years they've only been kidnapping a few times, 11 times. Almost all of those were false imprisonment. But what's cool is we can see even the exact addresses where those took place. Runaway, let's say, I'm interested in youth health particularly. I'm interested in runaways. So I can look at the incidence of runaway on average about, one runaway every 2 to 3 days. And I could look, now at this data frame of all the runaways, where they happen, and we could, calculate the risk of runaway by zip code or by time or day of week, things like that I don't think, as far as I know, anybody's doing. you might be a college student and interested in where the parties are, and one proxy for a good party is if the police get called. So we could look at, for example, parties, and you can see that that doesn't happen very often, right? For now, let's stick with assault as kind of our term of interest. And we can now make some visualizations, right? Because we have this geographic data, we could see where assaults have happened. I'm going to use a library up here called rcharts, RGDAL, and this kind of interfaces with a library called Leaflet, which is an open mapping library. Now I have this interactive map of Gainesville, and I can see all the crimes that have happened with my term of interest being defined up here, assault. I live close to Main Street, right around here, so 2nd Street. And look, there's an assault that happened right by my house last July. I was out of town. That's nice. This assault is basically at my house June, so it's been a while. Maybe we're due. Let's go downtown and we can look, aggregated assault. This was a year ago. And of course we could filter just to look at more recent things if we wanted. We don't necessarily have to do interactive maps. We could do static maps and see, where Gainesville police have gone. You can see once in a while they end up here in St. Augustine or down in, I don't know, Broward County or whatever that is. That's interesting. But maybe we're more interested in what's happening in Alachua County, right? So here's Alachua County, and you can see these little dots all mean a crime. If you're living out here way west or east, of course there are not a lot of crimes, but there aren't a lot of people. If you're living here downtown, university area, there's a lot more crime. Maybe we're interested in the zip codes of each of those crimes, because it's too much to, analyze at latitude and longitude. And so now we've made the zip code, so if you extracted the zip code, now in GNV there is a column called zip. And maybe we want to look at the number of crimes by zip code and, explore, visualize that. And so here's the number. This is overall time. We could, of course, I'm sorry. I forgot to load one library. So here's overall time, or the last 3 years, where crimes have occurred. And let's say we want to adjust for population, we can do that as well. I personally have a preference for these interactive maps because when I see a trend, I want to explore a little bit more. And so there's a lot of tools out there that you can use for interactivity. One is Google. For example, these lines of code here sent my data to Google's API, and then I'm running this locally, so it's not like, it is of course using Google's API, but it's not available anywhere else on the web. And now you can explore a little bit more and see burglary to business here, or, petty theft, or driving under the influence, all these different crimes that have happened around Gainesville. It's pretty interesting data, right? If we, like I said, we're interested in zip codes, so maybe we want to plot zip codes, kind of aggregate data at the zip code level, but we want to do that interactively as well. Again, using this leaflet library, we can create a GeoJSON file, which, it's interactive, and so you can zoom in and out, and you can see different population and explore a little bit more interactively. Again, all of this is used both in R and the browser, but R is what's generating the stuff in the browser. Now we're going to explore some weather data, and it's not chosen randomly. There's some research that suggests that weather is correlated with crime. So for this example project, let's see if we can find assess weather's influence on crime and see if it's statistically significant. So we are now, give me one sec. We're going to load in this package called weather data, and there's similar packages in Python. I don't think any exist in SAS, but there'll be some ways to do that in SAS, I'm sure, as well. And we'll get data for 2013 through 2015. We're going to bind those data frames together, and we're going to end up with this nice data frame called weather. And it looks like this. We have a date, max temperature, minimum temperature, and precipitation. Clean it up a little bit, and then we're gonna plot. We want to just quickly explore what weather looks like. So this is maximum temperature, and down here is minimum temperature, and that's kind of cool. We can see, the trends. Of course, there's seasonal trends, summer, winter, and let's kind of look at where we are today, minus a year ago and minus 2 years ago. Here's where we were a year ago, 2 years ago. Of course, today we don't have the weather yet because it hasn't been reported. But so we want the number of crimes each day in each zip code, and we're going to go ahead and create that, and then we're going to join that to our weather data by date. So we have kind of this master data frame we're calling TS that has both weather and number of crimes. So it looks something like this, like the date, the zip code, the number of crimes, the temperature that day, the minimum temperature, the precipitation, etc. We think that weekdays might be a confounder for, crime. So we can get a day of the week variable. And then we're going to construct a model, a linear model in which we're predicting the number of crimes, as a function of the zip code that you live in, the rainfall that day, the maximum temperature, and the day of week, right? And we're doing this in the TS data frame. So this is a pretty simple model, and of course it probably has some problems with it. Actually, I took out rain because I remember seeing that it wasn't significant. Now this model, the results look like this, basically. So relative to Monday, for example, Friday and Saturday both have an increase in crime. Sunday has a slight decrease. Thursday, Tuesday, all of those are higher, but it looks like the big one is Friday, is the day with the biggest risk for crime when controlling for other factors. You can see zip codes are all pretty significant. But now we have a model that explains 60% of the variance in crime in Gainesville just by zip code, where you live, and what the weather is that day. Now I looked up the weather for tomorrow, and it is a max of 82 degrees. It's a 20% chance of rain of 1 inch, so I just said that's 0.2 inches. And of course tomorrow's Friday, and here's all the zip codes in Gainesville. So now with our model, we could actually predict the crime for tomorrow. We could make a crime forecast, right, for each place, and then tell the police where they should be. We can do that, and it looks like this. You can see here's our predicted number of crimes in each zip code using our historical data and modeling it. Of course, we might want confidence intervals on that, so we can add those. And now I have a model, or a prediction data frame here, which says that tomorrow, April 3rd, in zip code 32601, temperature at 86 and this much rainfall, being a Friday, there will be 12.4 crimes, and I'm 95% sure that there will be between 7.4 and 17.4. I live in zip code 32601, so this makes me a little uncomfortable, but maybe those of you that live in, say, 32643 are happy to see something like this. So it's an oversimple model, but it shows you that just the availability, the scope of the data available, weather, crime, geographic, it's all there, and it's just waiting for people to use it.